All right. Let's do this. Let's read this. So, sketch a graph of a differentiable function. So if it's differentiable, it has to be continuous. Right? Differentiable guarantees continuity. So differential function f of x over the closed interval. So we're going to graph from -2 to 7, where f of -2 equals f of 7, and they're both -3. Let's plot those right now. So f of -2 is equal to -3. So let's plot that point right there. F of 7 is -3. Okay? We also are told f of 4 is 3. So f of 4 is 3. So let's plot that point right there. F of 4 is 3. And the roots of f of x occur at x equals 0. So put a root, so put an x-intercept at 0 and at 6. So that was all given to me before I even looked at the table. Then it tells me this. Okay, easy, right? Up to this point. All right, here we go. Between -2 to 0, the derivative is positive, which means we're graphing f, right? If the derivative is positive, that tells me f is increasing. But look at also this. It also tells me the second derivative is negative, which tells me concave down. So how do I draw increasing and concave down? Wouldn't it have this curvature right here? Cool. Okay. Now, I probably need, look at this. It tells me at x equals 0, the derivative is 0. And the second derivative is 0. Okay? All right, so be careful there. The second derivative is 0, and the first derivative is 0. That means I have a critical number here. Now, everybody look here. Look here, though. That is not a relative max or min. Why? It continues increasing. But look at this. Look at this right here. Everybody follow me. Look at this one. The second derivative is 0, so it's a possible point of inflection. And it is a point of inflection. Why? Concavity changes. Can you all follow me? So from 0, and then look at this interval. This is from 0 to 2. It's going to keep increasing. And it's going to do this. I'm going to change concavity, and I'm going to do that. Now look what happens. At x equals 2, look what it says the derivative is, 1. That means I'm going to have a tangent line with the slope of 1. But then look. The second derivative is 0, and then look to the left and right. See how concavity is changing again? So what's going to happen? It looks like this. It looks like this. I'm going, and something like that would, and then look at my cursor. Would you all agree that looks like approximately a slope of 1, that tangent line? I don't like, I messed up here then. That looks like a slope of 1 too. If I was going to graph this one, you don't have to erase it, but this is what I'm going to do. I'm going to be even more extreme with my curvature over here. I'm going to do this. Now I definitely, you see how I definitely have a 0 slope right here? And then I'm going to go here. And now I definitely look like I feel good about that being a slope of 1. Remember, this is a sketch. Can everybody see there's a point of inflection here and here? Yes? Okay, let's graph from, now where am I graphing from? 2 to 4 on the increase. Okay, we already did this. Okay, I got to go to x equals 4. My derivative is 0. And then I go from increasing to decreasing. Be careful here. My concavity didn't change. My concavity does not change from 2 all the way to 7. I got a concave down. So I need to do this. I need to come in here and have a curvature that's going to remain concave down the whole time.